Okay, we're looking at forces, and we've seen that a force is an interaction between two objects, and it can be a push, a pull, or a twist, and it causes a change in motion, direction, or in shape. So here you can see on page 280 that you can see the let's get that going. You can see the pushing force and you can see the pulling force here. Now forces are measured in newtons, which is a capital N, and it's named after Sir Isaac Newton. Seeing where there is what a force can do. A force can get something moving, can speed it up. When something moves faster, it's acceleration. When something slows down, deceleration. So it's changing a speed. A force can change the direction that something moves, and a force can change the shape of something, such as when we crush a can. Now, we use various tools to measure a force. A force, gravitational force, that's weight, is the force gravity exerts on a body, pulling it towards the center of the earth. So we can measure that force using a spring balance. We're all familiar with bathroom scales, and also we know how to use electronic scales. Across the page, we need to be able to draw forces. A forces diagram has arrows in it. The arrows indicate whether the forces are balanced or not balanced. Now we can see in figure 7.17 the forces on the bike. There are four of them. The gravitational force going down, the upward force going up, driving force going forward, and friction or drag, air resistance, tyres on the ground, and so on. They are balanced. That bike is not moving, somehow sitting there, but that is balanced forces. Forces acting on an object can be balanced or unbalanced. When we draw forces, we must use a forces diagram and the arrows. The arrows indicate whether the object has balanced or unbalanced forces on it. Now, when the bike is moving, when it's moving forward, accelerating or changing speed to go forward, then the driving force is greater than the friction. The other two forces are equal. When it's slowing down, right, the friction force is greater than the driving force, so it's changing speed or decelerating. And we indicate that by the length of the arrows. The length of the arrows, very important. Moving across the page, inertia. Inertia is the disinclination of a body to change its motion. So if a body is stationary or if a body is moving forward, the inclination to stay in that is called inertia. So when you put your school bag down in your bedroom, it will stay there until something happens to it. Someone could lift it, they could push it or pull it to make it move. But if left alone, it will stay as you left it. Okay, this is called inertia, things staying in the direction that they are. If you're going around a bend in a car and you can feel yourself hitting up against a door or something like that, it's because you are tending to go in the same direction, which was a straight line. Now, there are some impact force, of course, when you run or when you jump or those sort of things, and footwear is designed to reduce the impact it has upon us. Now, some car safety features. You can see that if a car comes to a grinding halt, everything is moving forward in the car. That's inertia. So you would be wise to just have a read of that and see how airbags play a role in that.